We present the Empowerment-regularized maximum entropy inverse reinforcement learning framework that simultaneously acquires both underlying reward functions and policies from expert demonstrations. Our method transforms the reward by adding an empowerment-based potential function. Empowerment is a mutual information-based theoretic measure. Given a state, it quantifies the extent to which an agent can influence its environment. Our method learns empowerment through variational information maximization in parallel to learning the reward and policy from expert data. The empowerment acts as a regularizer in our policy update objective function. This regularization prevents premature convergence of the policy to local expert behavior, and therefore leads to generalized policies that in turn guide the reward learning process to recover near optimal rewards. We evaluate our learned rewards on transfer learning problems that include the following two scenarios. In the first scenario, we change the agent dynamics during testing. The reward function learned on a four-legged ant is transferred to train a crippled ant whose front two legs are disabled. In the second scenario, we change the environment structure during testing. The reward function obtained on a maze with the left passage is transferred to a maze with the right passage. Here we present the first transfer learning scenario where the agent dynamics were modified during testing. Note that unlike the four-legged ant, the disabled ant cannot move sideways. Hence, it must rotate to run forward. In this scenario, it can be seen that our method exhibits expert-like behavior, whereas other state-of-the-art methods fail to recover the ground truth reward function. Also, note that EAIRL with state-only reward fails because it is not able to recover the action-dependent terms of the underlying reward function that penalizes high torques. Therefore, the agent shows aggressive behavior and flips over. In the second scenario of transfer learning, we change the environment structure during testing. It can be seen that in this scenario, our method and EAIRL with state-only reward exhibits expert-like performance, whereas the EAIRL with state action reward shows poor performance. We also evaluate the policy learning performance of our method on several high-dimensional control tasks, and it is observed that our method performs comparably to state-of-the-art imitation learning methods. In conclusion, we present an approach to adversarial reward and policy learning from expert demonstrations by regularizing the maximum entropy inverse reinforcement learning through empowerment. We show that our method recovers both ground truth reward functions and expert-like policies by evaluating it in challenging transfer learning and control tasks.